This lecture is on electric dipole and quadrupole. Yes, we have studied about single electric charge, but there is a possibility that the electric charge is found in some combinations, like in the form of dipole, in the form of quadrupole, octopole, and so on. We will discuss this in this lecture. In this lecture, we will discuss about arrangement of electric charges in various forms. Whenever we have more than one charges, then we observe the effect in the form of dipoles, in the form of quadrupoles or octopoles. Two electron, two charges may join, or four charges may join, or eight charges may join. We will discuss the significance of dipoles, dipole moments, significance of quadrupole, and their applications. Basically, we talk about electric dipole after single charges. Most of the time, we have electric dipole behavior. This figure gives the idea of what information we need or what information we can obtain with this dipole. With the electric dipole, these are much more common than isolated charges and are characterized by dipole moment. Whenever you have dipole, you will observe some dipole moment. And we also work on calculation of electric field and potential due to this dipole. Whenever we place this type of dipole in an electric field, external electric field, then we study the behavior of this dipole in electric field, work on the dipoles in electric field. We will also discuss torque on the dipole and energy of the dipole. These dipoles are very important in dipole moments, molecular dipole moments, and water molecules. Even we have developed many applications of dipoles in water molecules. I think all are aware of this and are also using the microwaves. Microwave is based on orientation of water molecules. Here water molecules gives a behavior of dipoles, and we use this to get the heat here, to generate more heat immediately. Dipole also used for studying polarization of dielectrics and capacitor. We will study these topics also in other lectures. Whenever we use a term electric dipole, the electric dipole moment for a pair of opposite charges of magnitude q is defined as the magnitude of charge times the distance between them. Actually, The dipole moment is multiplication of two things. The magnitude of same charge. The condition of the dipole is both have the same but opposite charge. Magnitude of same direction is opposite. The one is positive, one is negative. Now, if you are having these two charges, they form a dipole. We have this is separated by a distance d. Now, this have moment that is called magnetic moment, and see the directions. The direction is from minus to plus, where the electric field direction is plus to minus. This dipole moment is a product of charge and separation between these two. And it is always towards the positive charge. And yes, P is equal to Qt. This P is also a vector quantity. It is a useful concept in atoms and molecules where the effect of charge separation are measurable, but the distance between the charges are too small to be easily measurable. It is also a useful concept in dielectrics and other applications in solid and liquid materials. In atoms and molecules, many times a dipole system is formed. So, whenever dipole is formed, you can study the effect of fields and other in this dipole. For dielectrics, this concept is useful because, as we know, the dielectrics are not having free charges, free electrons. So, no conduction is possible there. Whenever you give electric field to this, then to accommodate that field, the dipoles, it gives the behavior of dipoles. Slight shifting, displacement is there, shifting of positive and negative charge to accommodate the field. That is why this concept is very useful in dielectrics, and we have many applications like capacitors, storage of energy, exhibition of energy using this. The application of dipole involves the electric field of a dipole and energy of dipole when we place the dipole in electric field. If we want to calculate the field due to this dipole at some distance from this, that the distance is z, and which is very greater than the d. The d is the distance between the atoms or these electric charges, then the dipole field can be written as 1 upon 4 pi epsilon 0 minus p over z cube. We have discussed this in a separate lecture, calculation of electric field. But it can be calculated in two ways. in polar direction and in axial direction and in perpendicular direction. Here I have shown in perpendicular direction. And this value gives the idea of dipole field. Here we have shown the electric dipole. If the dipole is there, it forms a dipole field. This field is similar to magnetic dipole field. As we know, for a positive charge, the we always use field in outward direction for the positive charge, and the field direction is inward for negative charge. Now, if the dipole is there, as we know, the dipole means the charge separation is very small between these two opposite charges. Then we observe such type of field lines. Field lines start from the positive and move to negative, like this. As you move away from the axial line, then you will observe curvature, and also the field lines become further and further, which shows that the electric field decreases as you move away. The electric field of an electric dipole can be constructed as a vector sum of point charge field of the two charges, and we can calculate the electric field either in axial direction or in perpendicular bisector direction or in various other directions. A general distribution of electric charge may be characterized by its net charge, by its dipole moment, its quadrupole moment, and higher other moment. As a matter of fact, single charge exist, but most of the time they form dipole or quadrupole. So whenever we talk about communication through electromagnetic waves, we study this type of behavior, whether the electric field is only due to single charge or due to dipole moments or quadrupole moments. Normally, after the single charge contribution, we have dipole contribution. But these two, not only these two can represent all field experienced. Whenever we have more than one charges accumulated at some place, it also gives quadrupole moment or octupole moment. So we have to take care of these things also. Whenever we use the word quadrupole, means four charges joined to give you quadrupole behavior. There is also a possibility to create octupole, where 8 charges join to give you octupoles. This quadrupole can be represented as two dipoles oriented in anti-parallel direction. However, of course, there are certain other ways to represent quadrupole. We will discuss these things in later in this lecture. In the figure, we have shown a quadrupole. Two pair of dipoles. An elementary quadrupole would be seen having zero charge and zero dipole moment at greater distance. Its interaction with an electric field can be quantified in terms of its quadrupole moment. So here we have shown here the quadrupole. Check. If we observe elliptical charge distribution, then this elliptical charge distribution can be represented by spherical charge plus quadrupole. And the spherical charge can be represented by point charge for accessing field and potential outside the volume of the charge. It follows that a spherically symmetric charge has no quadrupole moment. But if the symmetry is not spherical and you are having elliptical, then you have some contribution. One of the common use of the quadrupole is in the characterization of nuclei. The nuclei has charge but not dipole moment, since it is all positive. But if the nucleus is not spherically symmetric, it will have quadrupole moment. So, as we discussed in the last slide, the spherical behavior gives you the idea of quadrupole moment. So, same can be used here. Of course, we know the nucleus is always positive, but if the nucleus is not spherically symmetric, it may give some quadrupole moment. In nuclear physics, we study the quadrupole moment of nucleus also, and it helps to study the constitution of nuclei or the structure of nuclei, the behavior of nuclei. The quadrupole and high order multipoles are not important for the characterization of dielectric materials, because we know the dielectric materials consist of dipoles, and dipole fields are much smaller than the field of isolate charge. But in dielectrics, where there are no free charge, the dipole effects are dominant. There is no such circumstance favoring quadrupole effect. Quadrupole, octopole or multipole are important when for other arrangements. In dielectrics we have dipoles, dominant dipole. and so there is no significance of quadrupole, since they must arise from the same number of molecules as dipole effects. One of the scientists, Scott, says that the macroscopic quadrupole effects are smaller than dipole effect by about a ratio of atomic dimensions to the distance of experimental observations. So that is why it may not be important. There is another arrangement of quadrupole. In the last few slides, we have discussed quadrupole of opposite or antiparallel dipoles. But there is another possibility scientists discuss, that the dipoles in linear behavior, linear electric dipole. A linear electric dipole can be created by superimposing two electric dipoles of opposite orientation. If we do this, then their positive charge overlap each other, and this can be treated analytically and give one insight into the nature of quadrupole fields. The electric field from any collection of charge can be obtained from Coulomb's law by vector addition of the fields. The important thing in this linear is we have two electric dipole of opposite orientation, so that positive charge overlap. So on both the outer side, you will have 1 minus here and 1 minus here. But on the center, since you have overlapped this, so here you will have plus and plus. And so you will have 2q in the center, while q here, minus q and minus q here. This is another form, linear quadrupole. 4 are there. 1 from left, 1 to center to 1. This can also be, field can also be created here. In this, we have discussed the field due to this. We can calculate field at any place from here, just by taking the distance from here to here, and can be calculated. By symmetry, the total field parallel to the quadrupole moment cancel, and the resultant field perpendicular is written here. This is not derivations is not asked in the syllabus, that way we have omitted. This is the field. If you simplify this, we will get the answer. First, 1 upon r square should be taken out, and then use this, that d square upon r square is very less than 1, means the distance where you are calculating the region should be very far from this actual size of this dipole, octopole. So you will get this way. You can simplify this also. In this lecture, we have studied about existence of different kinds of arrangements of electric charge other than single charge. That is, we have discussed about dipoles, which is the dominant combination, then quadrupole, octopole, and so on. And the importance of these. Thank you.